Virtual threads are one of the biggest changes introduced in Java 21. But truly to understand them, we need to understand by simple question and answer model. So first we can see what problem do virtual threads solve. In traditional threads, the thread will be mapped to one of our operating system threads, making them expensive in terms of memory and context switching. As a result, application handling, many concurrent requests often need thread pools and asynchronous programming. Virtual threads are lightweight threads managed by JVM, allowing application to create million of concurrent tasks while writing simple synchronous code. So why we call the virtual threads or less in memory? We can understand that in detail. So, for example, in the norm before Java 21, that we call that as a platform thread, a native OS thread. Often, the default configuration we have XSS in our JVM. So, if you have 1 MB by default, then if we want to create 10,000 platform threads, so for each thread we need to have 1 MB memory, and it is into 10,000 if needed, nearly 10 GB of thread stack. But it is not case in the virtual thread does not own a dedicated OS thread. Instead of its stack represented as a heap based stack chunks. The stack chunks will be stored in our heap based. The stack chunks are allocated only when needed and and can be garbage collected. We already know the heap based memory is always garbage collected. When this virtual thread also comes as a stack chunks in our heap, it will be garbage collected. So if you ask how much memory this virtual thread will take, it is based on your the thread creation. What is the object you store, how much variable you want to store, it is based on that. But by default you don't need that 1 MB by default. That makes this virtual thread to use less memory. So we can see what is the difference between the platform thread and virtual thread to understand more. Okay. Platform thread is always managed by OS. It is, or that it is a stack memory. And virtual thread is managed by JVM. It is maps to one OS thread. If there is a one thread is created in Java, it is mapped to one OS thread directly. But in case of virtual thread, multiple virtual threads share the carrier thread which interact with the OS operating system. So multiple virtual threads can be shared and used by the carrier thread. That is the main advantage. So high memory usage, here low memory usage. We saw this one example above why it is a high memory usage and low memory usage. Platform thread, expensive to create, cheap to create, suitable for CPU bound work. Still, platform thread, as it is a OS operating system thread, it is suitable for the CPU bound work. The virtual thread is suitable for IO bound thread. This very clearly explains that it was not. So here we can see what is the platform and virtual thread in pictorial representation. You can see here when the platform thread is there, it creates the voice thread is created running. If any sleep or the voice, that particular voice thread will be blocked. Once only when it is unblocked or the sleep duration is completed, this voice thread is wake up and do all this action. When the thread task is completed, then the OS thread is destroyed. Okay. So when it comes to the virtual thread, when the virtual thread is created, it is mounted on a carrier thread and start running. When there is a blocking network IO or anything is happen, the virtual thread will be the carrier thread will be unmounted. The virtual thread holds the state of the thread still it is in the block state. And once the waiting time or blocking time completed, the carrier thread will be mounted and can be used. Here, the virtual thread holding the state during the block state where the OS thread goes and do some other OS thread tasks. So the OS thread was not completely blocked is the main concept here. So platform threads are heavyweight OS threads, while virtual threads are lightweight JVM managed threads designed for scalable concurrency. So what is a carrier thread? As already we saw above, carrier thread is a normal platform thread that executes virtual thread. So whenever if you see here, the virtual thread will be mounted on the carrier thread. The carrier thread will interact with the OS system. That is a main concept. The mounting and unmounting will happen in the between these two layers and this one. So what happens when a virtual thread executes thread.sleep? As understand, as already we discussed, in the platform thread it will be blocked, but in the virtual thread is parked. It will be holding all the states what it needs to be hold on. The carrier thread is released, the voice thread is released, and some other virtual thread can be executed during this period. When the sleep finishes, the virtual thread resumes and this one. So you can very clearly understand this improves our scalability because the OS threads are not left idle. So why are virtual threads used for web applications? Whenever, for example, if I have some HTTP call, some file IO operation, some network operations like some connectivity like peer connection or a node connection, some other connection, for example, I want to have a connection with my client or something like that, or these kind of operations, the virtual threads can be useful, where the platform thread is very expensive for these kind of small operation. So we can use virtual threads on s- particular part of functionality and the business areas, and platform thread on heavy load CPU load, for example, some a high encryption or high video composing or something like, which is a heavy CPU task, we can use for just a request response mechanism, file IO operation mechanism. We can use this um, virtual thread. That is a main. So next one, are virtual threads faster than platform threads? No, it is not. A virtual thread is something replacement of a platform thread. No, it is not necessarily. They do not make individual tasks execute faster. It improves the scalability by allowing many concurrent tasks with the lower resource usage. Virtual threads improve throughput and concurrency, not CPU execution speed. It doesn't increase the execution speed. For example, I can take in one of a real-time example. For example, in one of a telecom, I had initially, if I can connect with one of my neighbor node with 500 connections. Now I can do more than 500 or 2000, where still I can operate without any CPU issues, or any memory concerns, or any latency issues. I can execute the 500 2000 connections in my application. That is the main thing that you can understand. Okay, the concurrent number of concurrent tasks can be increased. That is a main functionality. As we discussed already, when should you use virtual threads? For REST APIs, Spring Boot services, JDBC calls, HTTP clients, file processing, microservices, message consumers. So in these areas, you can use the virtual threads. When should you avoid using virtual threads? Avoid them for CPU intensive work such as image processing, video encoding, encryption, machine learning, large mathematical computation. So how do you create a virtual thread? You can start the virtual thread like this, or you can do thread.virtual of virtual. Mostly in real time, obviously we will use executor service, which is the way to use threads in production style kind of application. So the executor service, you can see new virtual thread per task executor. Okay, so we will in the next one we can understand why we didn't mention about the size, everything, what is the stuff. These are the three ways that we can use. So what is executor.new surgery? It creates a new thread for every task. You can see, for example, I can do task 1, task 2. In real time, it is just an example. In production application, we will use in a different way according to our framework. This is one sample execution. So here you want to understand, you won't, like if it is a normal platform thread, you will say some size, some pooling. Here we don't mention it because it doesn't have any concern or limitation on creating the thread for per task executor. So you can create a number of threads for this executor service. That is a reason this number was not defined. Do virtual threads support thread local? Yes, virtual threads supports thread local. You know, you can create thread local like this. It start virtual thread and user dot. Yes, do you do virtual thread support synchronization? Yes, the platform thread and virtual thread are both are according to a thread, it is similar. Only there are the way the thread works internally differs, which increases our scalability. That is the one advantage. Yes, these fully support Java synchronization. Okay, what is thread pinning? Something related to the problem we see in our platform thread. Something like not this. The thread pinning is, what is the main concept is, we say when virtual thread is in sleep or when virtual thread is on waiting for something, we can use the carrier thread for our other task. But that is not possible when this thread pinning occurs. That is the main thing to here to explain. The concept is, again, I'm repeating that when the virtual thread main concept is whenever there is a thread dot sleep or thread dot wait, something is happening, there is some blocking is happening. The usage of virtual thread is that the OS thread, the carrier thread can be used by other virtual thread is the main concept. But the thread pinning, when thread pinning occurs, it cannot unmount its carrier thread because of this blocking operation, reducing the scalability. So you want to be very careful on this. For example, when there is a long running on synchronized blocks, when I'm doing some socket read and I am synchronizing that kind of block at that period of time, the OS thread, carrier thread cannot be released, cannot be unmounted. Or when we are using some native method, often we recommend not to use virtual thread during this native operation. That is the main thing. So some native blockings, certain blocking operations that cannot yield. So in one line, thread pinning prevents the carrier thread from being reused while the virtual thread is blocked. What happens during blocking IO? Yeah, the same thing. And I told you, right? Starts the virtual thread starts execution, blocking for wait for IO. It's parked by the JVM. This is the same concept. How many virtual threads can be created? There is no fixed limit. The practical limit depends upon the available memory, application workload, number of tasks, and how much memory that you used in your virtual thread. For example, if you have inside a thread, you have created a map which have storing of large amount of data. It is based on your thread creation also. Are virtual threads or daemon threads? No, by default, virtual threads are user threads, not daemon threads. They keep the JVM alive until they complete, just like regular user threads. So, can virtual threads replace reactive programming? Yes, it is possible, but not 100%. Still, reactive programming has its advantage, having a stream composition integrating with the reactive ecosystems. So it is not 100% replacement of reactive program. It has its advantages, but what are the advantages of virtual thread? As we already seen several times, it is a lightweight, low memory usage, millions of concurrent tasks, simple blocking code, better scalability, reduced need for thread pool tuning, easier debugging compared to what are limitations of virtual threads? They do not speed up CPU bound computation. Long running synchronization or certain native calls can reduce scalability. Excessive thread local usage can increase memory overhead. Performance benefits are greatest for IO bonds workloads and even some connection related stuff, thread creations also. So in interview, if someone is asking, explain virtual thread, what you can say? That is answer composed here. Virtual threads are lightweight threads introduced in Java 21 as part of Project Loom. Unlike traditional threads, which map directly to operating system threads, virtual threads are managed by JVM and multiplexed onto a smallest set of carrier threads. This allows application to create a very large number of concurrent tasks with low memory overhead. When a virtual thread blocks on supported operations like IO or thread.sleep, it is parked and carrier thread is reused for other work. They are ideal for IO bound applications such as web servers, REST APIs, database access, and microservices, but they do not improve the performance of CPU bound tasks. Okay, so yeah, these are the questions that I have for this to explain virtual thread. So whenever nowadays, whenever we are upgrading one from Java 8 to 11, Java 7, 11 to 17, 17 to 21, we won't upgrade all the features when in our application. It is very rare we touch our code on this. But when we need some performance improvement, we think of replacing some part of code and improve our performance, and we do some optimization in this kind. In Java 21, this virtual thread is a very important factor, and even there are large number of applications where they want to increase their connectivity or some IO operation related applications, or want to upgrade to Java 21 only because of this feature. So that is also happening. So understand virtual thread very clearly. Thank you.